Hi everyone, it's already 2 o'clock. Let's wait for 2 more minutes for other participants. And as of the moment, we have reported 354 registered participants. So we only have 214 at the moment. Let's just give them 2 more minutes and then we'll start the program. Thank you. All right. So, hello and good afternoon, everyone. Thank you so much for your time and for participating the first leg of our free three-part live webinar on non-revenue water strategies from the specialists. As of the moment, we have 250 participants. So, hello to all of you. And it's an honor to have all of you here in Zoom. I hope you're safe and in good condition amidst the global crisis that we are facing right now. So before we proceed, please allow me to introduce myself. And my name is Karen Samante. I'm the co-founder and digital operations and marketing manager of AJA Marketplace. And I will be your host for today. So I'm not sure if most of you have experience attending a Zoom webinar. And, with all the quarantine and physical restrictions, we currently have I agree that technology has really been a great help, to keep us or to make us stay connected with one another. However, sometimes technology is also very overwhelming. So, briefly, let's just go through our webinar guidelines. So, if you will notice, if you've been doing a Zoom meetings before, if you'll notice this time you won't have the microphone and the camera or webcam functions. It is because we are in a webinar setup. So with that, in any case, if you would want to ask questions, kindly do that by typing in your questions through the Q&A function or button that you will see at the bottom part of your Zoom screen. And please refrain from asking questions which are not related to our topic. So also, just so you know, this webinar is recorded. We will give you a copy of that link together with a copy of the presentation slides later. And also, if you will be able to finish all the three parts of this webinar, which the next part will be on the June 22nd, another one will be on the 26th. So if you'll be able to finish that, we will send you a digital downloadable file of your certification. So the presentation proper will be 45 minutes. And then after that, we will have a short break. After the break, we will proceed with the question and answer part, which will only be for 15 minutes. So, in any case that you'll not be able to entertain your questions during the 15-minute time period, don't worry. Just make sure that you will not ask your question in an anonymous, um, or just make sure it's not an anonymous option so that we will know how to get in touch with you to answer your questions. All right, so our three-part webinar is presented to you by AJA Marketplace. AJA Marketplace is a multi-vendor online website wherein you can request for quotation from different manufacturers, suppliers, or distributors here and abroad. So, but then this is specifically for the water and wastewater related products and services. And using the same platform, you can also proceed to purchase order. And we really believe that this platform will be very beneficial for the end users and the purchasing team because it will make the procurement process more convenient for them. And also together with us today is the one who initiated AJA Marketplace, as well as this webinar that we are conducting right now. Let me acknowledge the presence of the CEO and co-founder of AJA Marketplace, Mr. Alan Gedam. And if you want to know more about AJA Marketplace, feel free to contact us or to just visit our website, aja-marketplace.com. And also, this webinar is made possible with the cooperation of the Philippine Waterworks Association, Philippine Association of Water Districts, Water Environment Association of the Philippines, or WEAP. And aside from that, this is in special participation of the water loss specialists from the International Water Association, or IWA. And with that being said, let me introduce to you our speaker for today. Some of you might know him or have met him personally. He worked for 2 years at National Mapping and Resource Information Agency, or NAMRIA, under the Coast and Geodetic Survey Division. Later on, he also joined Maynilad Water Services Inc., or MWSI, and worked as a non-revenue water engineer. During his stay at MWSI, he became a part of the joint venture of MWSI and NIA, where he got involved in the preparation of feasibility study and management strategies for water operators, primarily in local and other Asia regions. So he joined NIA 2013 and still with them, working full-time as an NRW management specialist and project manager. So you might already be bored listening to me, so let's get this started. Let me call on our speaker for today, Mr. Ryan Paul Baculinao.
Hello.
Hi. Yes.
Good afternoon, everyone.
Hello.
Hello.
Yes, we can hear you.
Okay. Sweet. Hello.
Yep.
Yeah. Okay. Just wait a moment.
Sure.
Okay. Thank you, Karen, for the kind introduction, and good afternoon to everyone attending the webinar. And for today's session, for today's webinar, Introduction to Non-Revenue Water, I will be focusing mainly on the water balance. And for those who have attended already a similar seminar or webinar, please bear with me. Before we proceed, I just want to share with you guys a brief history of the modern NRW management. In the past, water loss reduction activities were done in uncoordinated way. Interrelations were not properly understood, and the turning point happened in 1989 when the privatization of the UK water industry started. Then there was a need to become more efficient, and there has been a significant research that was done in the UK, and the results of this research work formed the basis for modern NRW management concepts and tools. Iowa Water Loss Task Force was established in 1997 to develop the standard water balance and terminology, as well as to develop the water loss performance indicators. The task force also develops and promotes international best practices in NRW management. At present, there are more than 200 active members from more than 40 different countries. And in the previous Water Loss Conference in 2018, which was held in Cape Town, South Africa, there were more than 500 participants from 40 different countries. Okay, so let's define first non-revenue water. What is NRW? Non-revenue water is the water that has been produced or pumped and is lost before it reaches the customers. Actually, NRW is also an efficient uh, performance indicator, performance of a water company. NRW can occur through physical losses from leaking and broken pipes, which are caused by poor operations and maintenance, lack of active leakage control, and poor quality of underground assets. NRW can also come from commercial losses caused by the under-registration of commercial meters, data handling errors, illegal connections, and water theft. Another cause of NRW is the unbilled authorized consumption, which includes water used by utilities for operational purposes, water used for firefighting, and water provided for free to certain consumer groups. NRW is the difference between the water supplied, the system input volume to your system, and the water sold, the billed volume. This is the simple and basic formula on how to calculate or compute your NRW. But we need to separate this into components for us to better understand. In the next slides, I will be discussing the IWA Standard International Water Balance and its terminologies. Okay? From the system input volume, okay, from the source, the water travels to our customer, okay? And that's our revenue water. And from the previous formula that I have shown you, the difference between the system input volume and the revenue water is your non-revenue water. The revenue water, sorry, the revenue water has two components, the billed meter consumption and the billed unmetered uh, consumption. The billed metered consumption is from all the registered customers that are metered, while the billed unmetered consumption is for the customers that are not metered and is paying for the estimated volume. Together, these two combined, this also form the your billed authorized consumption. Then we have the unbilled metered consumption. Okay, this is the volume supplied to the customers free of charge but metered. Generally, this is not significant, but sometimes it depends. For example, if there's a depends on the country and depends on the uh, policies of the government. In a country, before I handled a project in Africa, in their military facilities, they are supplying the military with water for free, but they are metered. So if you're supplying substantially big facilities, then the volume that will for the unbilled meter consumption will be significant. Then we have the unbilled unmetered consumption. Okay, and this one often seriously overestimated on purpose, just to mask other losses. Just to mention, in Australia, the Water Services Association, they only accepts 0.5% of the system input volume. And if it's higher than that, again, this is for the unbilled, unmetered consumption. If it's higher than that, the utility needs to justify why. But for us here in the Philippines and in other parts of the world, we can use 0.8% of your SIV, system input volume, if you don't know how to calculate, just for an initial estimate. Now, if you have already identified, estimated, and or calculated your unbilled and metered consumption, and it is more than 0.8% of your SIV, then perhaps you need to consider metering these consumers Okay, the unbilled the unbilled meter consumption and an unbilled unmetered consumption. This is now your unbilled authorized consumption. Okay, together the billed authorized consumption and the unbilled authorized consumption will form your authorized consumption. But if you notice, okay, if you notice, the unbilled authorized consumption is already part of your non-revenue water because it doesn't generate any revenue for your utility, but this is a legal consumption. Okay, now your SIV, the system input volume, minus your authorized consumption will be your water losses. Okay, as we can see here, the water losses, this one, will only be equal to your non-revenue water if this portion, the unbilled authorized consumption, will be zero. Okay, I mentioned before that sometimes utilities they put more here on unbilled and metered consumption to mask other losses. Okay, so if this is quite big, in return your water losses will be significantly reduced. Okay, so then we will have the unauthorized consumption. These are the illegal connections, water theft, etc. Then we have the customer meter inaccuracies and data handling error. These are the under and over registration of your customer meters. And these two will be your commercial or apparent losses. Then what's left will be your physical or real losses. The components of these physical real losses are the leakage on your transmission and distribution mains, leakage and overflows from the utility storage tanks, leakage on service connections up to the customer meter. Okay, it is very important for us to calculate the water balance for us to know the water loss situation in the utility. Okay, it will also reveal the availability and reliability of our data and our level of understanding. Sometimes, even the most basic information such as the system input volume, average pressure, supply time, length of mains, and the number of service connections is not readily available. The process of calculating each of the water balance components will reveal such deficiencies, and the utility will be able to take corrective action to close those data gaps and improve the data quality in return. Using the incomplete or inaccurate data for the water balance calculation will not help the utility. No, it will just produce it will not produce useful result for the utility. The results of the calculation of the water balance can be used for benchmarking for among other utilities. And if we are confident with the result of, of our water balance, it can be used as a basis for the utilities for the investment strategies and decisions. Now we go to the, no, I have shown you the table of the water balance. Now let's discuss the how to calculate the water balance step by step. The first step is for us to determine the system input volume. Okay, the SIV, the one that I showed you earlier. It may come from the utility's own sources or treatment facilities or from external bulk suppliers. Water losses, raw water transmission schemes, and losses during the treatment process are not part of these water balance components. Okay, then measured system input volume has to be corrected. The bulk meters or meters used for the SIV should be corrected for the systematic bulk meter errors. Actually, this is easy if all input is accurately metered and recorded. But in the absence of production metering, flow measurements such as with the use of portable devices, the clamp-ons, reservoir drop tests, if you have reservoirs, analysis of pump curves and pressure and pumping hours can be used for you to have an idea on your SIV. It's very important for you to understand that the accuracy of the SIV, or the system input volume, is the single most important factor for the accuracy of the water balance. Okay? Listed herein is the indicative examples of the bulk meter accuracy. We have the electromagnetic flow meters, ultrasonic flow meters, insertion probes, mechanical meters, Venturi meters, measuring wears in the open channels, volume calculated based on pump curves. Again, these are the best case scenario, the approximate accuracy range here. These are for the best case scenario. The actual meter accuracy will depend on many factors. Okay, so that's why we need to verify this from case to case. Okay. Now next, the calculating water balance. Step two is for us to determine the authorized consumption. In calculating the water balance, first, it is important for us to usually to calculate for a longer period of time. Let's say for a period of 1 year. Why? Because this eliminates the seasonality factor. But of course, you can do calculate for a shorter period. Let's say for 1 month. It's up to you. But just a suggestion, if you want to eliminate the seasonality factor, it's best to compute for a period of 1 year. Okay. Then for the build meter consumption, this you can get build consumption. This includes your authorized build meter and the meter consumption. You can get this data from your billing department or your commercial department. It is important for you to check the correlation of the meter reading and billing cycle with the period for which the water balance will be established. As I mentioned, if you want this to be a shorter period, you better check the meter reading and billing cycle. And for the estimated consumption, you should assess the quality of the estimates because the over or under estimated quantity will be put or will become your commercial losses. Okay. Now, if for the unbilled metered consumption data, if you have any records of there are customers that belongs to this category, get the records if there's any. Okay. Again, I mentioned earlier that the volume of this one is not that significant, but can sometimes be substantial. Then the unbilled unmetered consumption. Okay. Again, if you have this one, because usually the firefighting, okay, some of the fire hydrants or most of our fire hydrants in the Philippines are not metered, especially for the water district. So if you have this consumption and you don't have an idea yet on how big is this one, you can still use the estimate of 0.8% of the SIB. Now again, just want to repeat, if this will be greater than 0.8% of your SIB, consider metering those consumer or customers that are under this unbilled and unmetered consumption. Okay, then step three is to estimate the commercial losses. Okay, actually this part, the estimation of commercial losses is quite challenging. Okay, because we need to estimate uh, water theft in the utility. Again, in one of my projects, the utility manager also has a problem on estimating the water theft because it's really true that if we know already how many illegal connections we have or how many customers or people are stealing our water, then we would have already plugged those illegal connections or apprehended those people that are stealing water from us. Okay? So for unauthorized consumption such as illegal connections, misuse of fire hydrants, vandalized, tampered, or bypass consumption meters, and corrupt meter reading practices, we need to discuss this one with the head or the unit in charge of this of the illegal connections. Then we can ask help from them how to estimate for this one. Okay. Then for meter other registration, we need to conduct meter testing for working customer meters. These are the meters installed in the field. All actually in the projects that I've been handling, usually we test 2% of the total number of meters installed in the field. So you take a random sample, 2% of the total number of meters in the field, you test that, then for you to be able to calculate the meter under registration. And at the same time, you also need to determine the over and under registration of the meter part. Okay? Once we have conducted all this, then we can now calculate the physical losses. Okay. In calculating the physical losses, so actually we already have the system input volume. Then if we have already the authorized consumption commercial losses, we just subtract those two and we will have the physical losses. But sometimes the results are inaccurate and unreliable because of the poor accuracy of the SIB, unknown customer meter accuracy, and high levels of water theft. Because of the different accuracy levels of the different water balance elements, okay, then there is a need for us to conduct probability analysis in the water balance. Okay, here the quantities are the confidence limit of 95% should be applied to all water balance data. Okay, these define the boundaries within which we can be 95% sure that the true value of a particular component of water balance is within X% of the true value, meaning the uh, with error margin. So to better illustrate this one, I have provided an example on how to calculate this. Okay, we are given with okay the system input volume with a value of 300,000 cubic meters per day with meter error, margin error of 2% at 95% confidence interval. Then we have the build consumption from our billing and commercial department of 200,000 cubic meters per day. Of course, the error margin will be 0% because we are sure of this one. Then from the first formula that I have shown you, we just need to get the NRW, we just subtract 200,000 from 300,000, we will get 100,000. But we don't know what will be the effect on the error margin of the NRW because of the error in the metering. Okay, so this we will calculate. Then we have estimated we have the unbilled authorized consumption. So we have 5,000, and since we are not sure or there's a high uncertainty for the unbilled authorized consumption, 50 plus minus 50% was given as the margin of error at 95% confidence interval. Then, okay, for you to get the water losses, you just simply need to subtract the unbilled authorized consumption from the non-revenue water, and it will give you 95,000 cubic meters per day. And we don't know also the effect on the error margin for the water losses. Okay, so this we will be calculating. Then for the commercial losses, we have estimated, this is given, 30,000 cubic meters per day. And with a high uncertainty, we have allotted plus minus 30%. Okay. Now to get the physical losses, we simply subtract commercial losses from the water losses. So 95,000 minus 30,000, then we have 65,000 cubic meters per day. But again, we also don't know the error margin at 95% confidence interval, which we will try to compute. Okay. Now this is statistics. We will be using the standard deviation, the probability analysis, and the variance. So for the system input volume, okay, we'll calculate the standard deviation for the system input volume and a build authorized consumption. Again, the formula is volume times the confidence interval, this one, over divided by 1.96. 1.96 is a constant. So we'll have here a value, here 0 because this is 0. Then we get the variance. We just simply square this one. Then we have this value. Then we add these two. Then we will get this one. Still have the same. 9,369,721. Then we get the standard deviation by getting the square root of this one. Then still be the same. This one. Then we calculate the error margin, okay, the confidence interval, okay, using this value, but with a smaller volume, not the 300,000 for the NRW. Then we will have plus minus 6%. So the plus minus 2% error in our system input metering gives us plus minus 6% error, margin of error, margin of error for the non-revenue water. Okay? Then we proceed now. With alveolar consumption, we also do the same. We compute for the standard deviation, then the variance, then we add these two, then we'll have this. Okay, then we calculate back, then we will get plus minus 7% error margin at 95% confidence interval. Then we proceed also with the commercial losses. We calculate the standard deviation, then the variance, then we add these two, then we'll have this value, we get the standard deviation and we calculate back the confidence interval. So as you can see here, okay, this, okay, small error margin has given us plus minus 17% of error margin for our real losses, plus minus 7% for water losses, and plus minus 6% for the non-revenue water. So what does this mean? Okay, the results, in the results, so with that data, so our NRW using that data can go for as low as 94,000 cubic meters per day or as high as 106,000 cubic meters per day. The commercial losses will be between 21,000 and 39,000 cubic meters per day. But for the physical losses, can be between 53,950 and 76,050 cubic meters per day at 95% confidence interval. So again, I have mentioned earlier that the system input volume is the single most important component of the water balance. So we need to be sure that we have the accurate data for that. Because the next, what if we have increased, okay, from 2% plus minus 2%, let's say that the error margin is quite high. Let's say 10%. So if it's 10%, okay, I've already made the calculation here. If it's 10%, this will be the effect. Okay, look at the range of value, the range where your NRW, the volume of your NRW water can lie. So it's between 70,000 cubic meters and 130,000 cubic meters. Your commercial losses, since you've already done estimation on here and assigned already the error margin at 95% confidence interval, it remained the same. But for physical losses, it is now wider also. It can be as low as 33,800 cubic meters per day or as high as 96,200 cubic meters per day. Okay, the uncertainty in the SIV will be magnified and will greatly affect the range of values of where the actual value of the NRW and the physical losses will lie. Okay, but okay, given this, you can try to redo or to recalculate this one, but assigning plus 10%. No, after this webinar, so and see and check if we will have the same results. Okay, but don't you worry because I just want you to show the concept on how the error margins at 95% confidence interval the uncertainties on the data will affect your water balance. Okay, so but don't worry because you don't need to do this tedious calculation whenever you want to calculate the NRW of your utility. Okay, there is a software called the EasyCalc. This is a free water balance software, which was developed by Roland Limburger, my boss, which is supported by the World Bank Institute, and you can download this for free from this link. Okay, www.limburger.cc. So from time to time, whenever there's changes, Roland is updating this software. Okay. Okay, in using this software, okay, besides gathering all the data on the system input volume, build consumption, unbilled consumption, unauthorized consumption, estimating your customer meter inconsistent data, handling errors, we need to gather the following additional information. First, the average pressure. Okay, the average pressure that you need is the average pressure that your customer is enjoying. This is the level of service and not the pressure. This is a common mistake. Not the pressure from your water sources or just after your pump station. That will give you wrong results. Okay. Then, if you have already the data for your average pressure, you can calculate your average supply time from that. So you also need this if you will be using this water balance software that I just shown you. Then length of mains. Okay, you can get the length of mains, total length of mains from your engineering, if or from the GIS if you have the GIS, or from the AutoCAD. And I hope that you get the latest one, the most recent uh, length of mains from your drawing. Okay. Then last, you need the number of service connections. Okay. Since service connections, the weakest part of the distribution network, often they leak first, okay? That's why NRW is oftentimes expressed in first in service connection. This is often confused with the number of customers. Okay, sometimes whenever we ask a utility if how many connections they have, they will give you the number of the customers they serve. That is wrong. Water utilities should identify, actually geolocate and record the service connection. If they have GIS, you can do this. But if you really have no idea on the number of service connections that you have in your utility, then can you start with the estimate? Initially, just an estimate. You can use the number of customers that you have. But again, just bear in mind that that is wrong. So that you can just proceed with your water balance, knowing in your mind that there is something wrong with the number of service connections and you need to correct this one. Okay. And again, there I strongly encourage everyone, especially for the water districts now, to at least try and calculate the water balance, your water balance. Okay, there so because if you do that, then you will see the data deficiencies of your utility. So you may have a wrong or unuseful result because if the inaccuracy is very high, but at least you will be able to identify where you should improve, what data needs to be gathered again, or needs to be improved. Then you can calculate that again until you have improved the accuracy of your water balance calculation. Okay, just to show the difference between the customers and the service connections. Okay, here's the figure. Okay, here we have a one customer to one service connection, one tapping. So okay, then in this example, the next one, we have two customers. Okay, they have customer meters installed, and you only have one service connection. So the two customers are sharing the service connection. So two customers, then you have one service connection. And here you have a meter banking, meter clustering, or sometimes they call this manifold. We have 10 customer meters, right? Sharing with one service connection. Okay. So these are what we need. The service count of service connections in your utility and that the number of your customers. Another example is a building. Okay. You have 22 customers. Okay. But it's being supplied only by one service connection. And another building, usually hotels or condominiums, where you only have one big meter supplying the whole building. This is like this one customer, one service connection. I hope I was able to make that clear. So to avoid the confusion. So service connection is not equal to your customers most of the time because there are some utilities where their policy is 1:1. They only install one they install one service connection per customer. So if that's the case, then the number of your customer meters should be equal to the number of your service connections. But in the Philippines, okay, here in the Philippines, that is not true. So because we have meter banking, clustering, manifold, and we have sharing of service connections. Okay. Okay. So over the years, there are many methods that have been developed no, for reducing NRW. But many water utilities around the world, also here in the Philippines, have yet to implement sustainable NRW reduction management. Uh, Many different factors affect the presence and the expanse of physical and commercial losses in the water distribution network. Before you choose which intervention methods to use, okay, the water utility must understand which factors are attributed to the physical and commercial losses in the system. Maybe a single or a combination of different methods that will be efficient for the economic of the reduction of the NRW. Okay, in the next slides, I will just show you the four principal intervention methods to combat or to address the physical and commercial losses. Okay, we have the four elements of a sustainable leakage control strategy. This is for the physical loss reduction. Okay, this big box. Okay, this is this square is a representation of your utility's current annual volume of physical losses. Okay, then the black box, this one, this is your unavoidable annual real or physical losses. Which means that it will be extremely difficult for you to be able to further reduce this unavoidable annual losses. So this is the minimum that you can achieve. Okay. Then the remaining gray box, these are the volume of your physical losses that can still be recovered using, okay, by doing active leakage control, speed and quality of repairs, pipeline and assets management, and doing pressure management. Okay. The next is the four elements of the on managing the apparent losses. Okay. Now this big square is your current annual volume of commercial or apparent losses. Now the black is your unavoidable annual apparent or commercial losses. This is the minimum that you can achieve. And the remaining gray area, guess what? Okay, these are the recoverable, potentially recoverable commercial or apparent losses. And this can be further reduced, okay, by addressing your data transfer and archiving errors, your water theft, your reducing the data billing errors, and your addressing your customer meter inaccuracy. Okay. Again, these two figures that I have shown you, I will not be discussing this in this webinar because it needs more time and it is the details of this will take longer, I think. Okay. Now, what are the benefits of NRW management? Okay. Okay, we want to reduce the NRW because of the financial gains from the increased water sale. The NRW, then the utility will have financial gains from increased water sales or reduced water production. Okay, if you were able to recover from your physical losses, you can supply those areas which are not yet supplied, and you'll get additional revenue from that. Or if you have already recovered your entire service area and you manage to reduce your physical or commercial losses, you can reduce your water production. You will be saving money from that. Okay, and the benefits also of reducing NRW, it defers the capital expenditures. Okay, many water utilities are facing increasing supply demand problems, and as the demand grows and we have finite water resources, it's difficult, expensive to develop additional water resources. Actually, reducing the real loss component of NRW is by far the cheapest and new water source for the utility. Okay. Then a benefit also for the NRW management is the more stabilized water pressure throughout the system that reduces damage to the infrastructure, thus prolonging asset life. Then we can benefit also for the reduced risk of contamination. If we have intermittent water supply, contaminants that accumulate while the system is depressurized will be flushed to the customers' homes once the system is pressurized again. So if we are able to manage successfully our non-revenue water, we can reduce the risk of this contamination. Then as we do the reduction in our NRW, then we will have the increased knowledge in the distribution of our distribution system. Okay, so in managing the NRW uh, level of our utility, actually I have identified four aspects that are very important for the success of the management of the NRW. Okay, the first one is the technical and the technological aspect. Actually we need the expertise, of course, the most recent technological advances that are available, okay, to help us in battling the NRW. Then the political aspect. Actually, many countries have a water strategy already in place and quite often consider water loss reduction to be important. But sometimes its implementation is usually difficult as it requires new forms of sharing responsibilities and a change in traditional consumer behavior. And water loss reduction is sometimes neglected, even if it presents more economical solutions. So this is really a challenge. Okay, sometimes in the political aspect, sometimes they prefer ribbon cutting over a new uh, constructed water source or deep well, okay, than doing NRW reduction. Of course, next the financial aspect. NRW management is capital intensive. Utilities need to secure enough funding to address NRW holistically. Of course, this has been a challenge for many water utilities, especially smaller ones. The challenge for the utilities to determine the optimal level of the investment for their NRW strategy. Okay, the trade-off between the value of lost water and the required investment to reduce this loss requires careful economic analysis. Of course, we need money, okay? We need money to reduce NRW. Or we need this to pay for the technical and technological aspect, of course, on the operations. Okay. Last but not the least is the management aspect. Okay. Long-term water loss reduction will only be successful if the water utilities top management is fully committed. Now, there's a need for a change in the management focus, as well as appropriate benefits and incentives for the entire staff, so to motivate them. Okay. Now, before I end, actually, even just if you miss just one of this one, if it's not, if you don't have the support, okay, from your management or even from your financial, you don't have the money, no support from your from this one, it will be extremely difficult or very challenging for the NRW management to be successful. Okay, because here your management and sometimes the politicians, okay, especially for the water district or some water districts, they're the one that will decide, okay, how much money if they have budget for a certain project. Okay, so if there's no money, okay, there's no money, then you cannot afford this. Okay, and even if you have this, you don't have, and if you don't have the support of your management, even if you have the best or the top engineers in your utility, he or she cannot do anything about the level of your NRW. Okay, so these four should be, you should be okay. Sorry, these four should be present, no, for us to be able to be successful in our NRW management. That's all. Thank you.
All right. Thank you so much. Thank you so much, Mr. Baculinao, for an enlightening and information-filled presentation on non-revenue water. And we know that there is still a lot to know more about NRW, but we appreciate the detailed visual presentation and helping us, reminding us the importance of NRW management. And we know a lot of water utilities suffer from the huge financial cost of the non-revenue water. So really managing NRW better and having a holistic approach in this is very important. So again, thank you so much, Mr. Baculinao. So as of the moment, we will just have a quick break. It's actually just a 10-minute break. And while doing so, let's watch this video. And also, please feel free to type in. I already see here several questions being raised. So just type in your questions in the Q&A button that you will see on your Zoom screen. And we will address that. Of course, Mr. Bacolina will address that later on. So let's just have a quick break. Thank you. Hello again, everyone. I hope most of you are still there. So as I see here, we have around like 16 or 17 questions in the Q&A panel. All right, so most of these are very technical. So may I call on Mr. Ryan Baculinao? Are you still there? All right, so I'll read out the question and then I'll
Hello.
have, of course,
Yeah.
Ryan to answer. All right. So first question is, how do I read this? All right, we have here from Jexter Flores. The question is the IWA or water balance also accepted by LUA? Is the 95% confidence level can be used in monthly progress reports submitted by local water districts to LUA?
Okay. I've also participated and did some also training that has been attended by uh, the water districts. Actually, we will be happy now if if all the water districts will be using the same uh, water balance, the type of water balance we're using. But I'm not sure because I think Lou is the one who should be answering this one. I'm not sure if in their policy they are accepting this one. But I believe that there are already talks or discussions between water districts and LUA regarding this one. But I think it's the LUA who can answer this one.
Mhm. All right. Thank you so much for that. And next question from Subod Luitel. I'm sorry if I was not able to pronounce it correctly. So can you explain the percentage error thing again? How are we going to get those figures in real scenarios? Like you have used 2% for SIV and plus and minus 50% and plus and minus 30% for other losses.
Okay. First, for the SIVs, the table that I've shown you, the errors for different types of meters, those are the best case scenario. For the system input metering, you need to do a check whether you have a clamp on parallel measurement to get the errors in those meters. Now, for others, like the 50%, 30%, I think this pertains to the commercial losses and unbilled consumption. Okay, so here you really need to study your billing data, and for the commercial losses, you need to do uh, meter testing, meter testing for you to establish at least the meter under registration. Okay, and I think uh, for this one, especially for the water balance, I think it needs to have I don't know, for the organizer or maybe from Iowa also. eh, I don't know if it's possible to conduct another webinar just discussing the water balance and how to use it. But I still encourage for those that participated in this webinar to try and download the water balance software from the website that I've shown you and try to fill in the needed data. So at least you will have already questions that can be answered from questions. Then you'll know what data that you are missing and what data needs to be put in and how it should be gathered or should it be extracted, where to find it. And this one from Subod Luitel, uh, you need to start filling in the information first for the water balance for you to have an idea on what's missing. For commercial losses, you really need to do some estimates. And for that estimates, you really need the help of your commercial people from your commercial department. Okay.
All right, thank you for that, Ryan. Um, Maybe I'll just try to check these questions depending on the time when it was submitted.
Yeah.
So 239, Prajan Hada, is length of mains means total length of primary, secondary, and I believe this is tertiary line in
Yes,
EMA.
all. Yes, all.
All right.
All pipelines.
Mhm. Okay. Then let's have from one, Chacon, how do you validate the uncertainty assessments in WB?
Actually, first for the SIV, I already mentioned you need to do you need to do parallel measurements. That's one way. Okay, for the meter under registration, you need to conduct meter testing. For others, you really need to do estimates. But again, you need data, at least a basis before you do this an estimate, and not just guess for those estimates, so that it can support also your claim, no, for your estimates.
All right, thank you for that. Then 246, Stephen Batak. Could you further explain the difference of UARL and ELL? Which is usually smaller, UARL or ELL?
UARL is the minimum. Okay. ELL can be maximum as low as this, but will normally be higher, no? Depending on the variable cost of your water.
All right, thank you. Okay, so we have Stephen Batak again. Do we have a value investment versus NRW reduction? How many, oops, where did it go? Yeah, how many M, MUSD per MLD of NRW?
No, actually, it will depend on the local situation. How bad is the condition of the network? How many kilometer of mains need to be replaced? But a good first guess is 600 USD per cubic meters per day NRW reduction.
All right, thank you. Next question. Okay, Ryan Fuentes, 252. Are there any existing regulatory or legal frameworks to manage NRW in the Philippines?
That I don't know. Maybe from the LUA. LUA knows
Mhm,
this.
mhm.
Okay, or for the soon to be established or established already Department of Water. But I don't know yet if there's about this one.
A
But I
regulatory
think
body.
but I think it's they have a target, no, for the especially for the water districts. They have already this targets every month or every year that they need to achieve. But uh, but the problem maybe is the on how to properly assign the targets, no, for the water districts.
Mhm. So thank you for that. And thank you as well, Ryan Fuentes, for the question. All right, we have from Tego Kayono. How to find a legal connection, inaccuracy customer water meter, how to reduce commercial losses about meter reading.
Actually, a whole session, no, next for it. No, but for the illegal connection, one thing that you can do, if you can do the GIS, plot all your customers, so you will be able to identify which household has no meter, has is not connected to your utility. Then you can start with that. You can start to investigate those households which are not connected to you, because maybe they're using other water sources. Okay, it's not that immediately they are using illegal
Mhm.
uh, water, but for an accuracy of customer water meter, you need to study this one. Because besides the meter testing, you need to know how long before your how many years before the meters that you're using will start deteriorating. Okay, so there's still the customer meter analysis for this one, so it's not fixed.
Thank you. And then, what is the best percentage assumption for illegal connections for WB computation from Wirla Reyes?
Again, you need to talk to the department or in your utility who's in charge with this one. So you need to at least look into the data and ask also for their inputs to be able to uh, do estimate, okay, to estimate the illegal consumptions in your area.
All right. Okay, just let me know, Ryan, if this has been, so other questions has already been addressed, you know, earlier or
Okay.
through the other related questions. So Peter John Mostrado, good afternoon. May I ask, can you share us of you have if you have an actual experience to quantify the commercial losses in percentage only, or any study regarding these losses? I have demographics of residential accounts BV 30% and commercial BV 70% with an average consumption per month of 22 cubic per meter and com 147 cubic per meter. The ratio also of the connections are 70% residential and 30% commercial. Hope you can
Oh, okay.
cater my question.
Okay. For this is Peter John Mostardo. Yes, of course. I've been doing so many water balances already. Okay, using the software that I've shown you. So I've already quantified commercial losses. But again, commercial losses is not about because you've been mentioning the residential accounts, commercial accounts. So this is about the your metering, the commercial losses on your metering. So you need to conduct meter testing here. But remember, there's still illegal connections for your commercial losses. Then you have data handling errors. Okay, so I think here you need for this data that for the data that you just gave us, you're pertaining to your bill consumption. So for the commercial losses in your bill consumption, so you need to conduct meter testing for you to find out the meter inaccuracy. So you can calculate for the commercial losses due to meter inaccuracy. But for others like illegal consumption, then you need to look into this and do an estimate again based on the data that you have by consulting the department or unit in your utility that is in charge of this one.
Mhm. All right. Thank you. And then Nicole Pajaron, why is the error for build metered consumption zero?
Oh, okay. In the example that I just gave you, it's zero because that is your build volume already. You have already charged your customer with that. Okay. So you don't want to say that with your cost even for a customer. No? You already charge your customers with that build volume. So you are sure already with that one. So you don't need to assign any error on that one.
Okay. And then can you please, from Alvin Asingwa, can you please elaborate further the unbilled meter consumption? Type example.
Okay. Unbilled, unmetered consumption.
Yes.
Usually in the Philippines, the unbilled, unmetered consumption. One example is the use of the uh, fire hydrant. Okay, our Bureau of Fire Protection, they can use the fire hydrant. Okay, I don't know if there are already regulations in other areas of the Philippines, but what I do know is that they are not being charged on this. But some utilities, they ask the Bureau of Fire Protection to at least make a log on how much they are consuming. But of course, this will be also an estimate from the BFP. So this is one example of the unbilled, unmetered consumption. Also, some utilities, they're using water, okay, for flushing, but of course they're not charging themselves. So these are part of your unbilled metered consumption, unbilled unmetered consumption. Okay, anything that is legally that you're giving away legally that is not metered, this is under your unbilled unmetered consumption.
Mhm.
But again, that's a reminder, if the total uh, volume for your unbilled unmetered consumption will be more than 0.8% of your SIV, okay, for your estimate, then you need to start considering installing meters for those customers.
Okay. Thank you. Now, Bernardo Hornilia. So this is a lot. How to estimate the following, or this might be able to answer through the app that you showed earlier. So how to estimate the following: leakages visible, leakages non-visible, SC under registration of meters, illegal connections of different types, is unaccounted for water differs from non-revenue water? What is the industry challenge in the reduction of NRW in the Philippines?
Okay. Actually, for all of this, I suggest for you to use the water balance software that I have shown you. But I can answer for the other items, unaccounted for water. It depends on your definition. But from what I read, especially also in the for the some water utilities, the unaccounted for water, the difference between the unaccounted for water and the non-revenue water is the unbilled consumption. For some utilities, no, they include the unbilled consumption for their accounted water, but the unbilled consumption is included in the non-revenue water. Okay, for the okay,
All right, thank you.
hope this is clear.
You might want to choose which question to answer as well, Ryan.
Yeah,
So,
usually, uh, okay, this one from Oliver Absalon. Please explain further what commercial losses means. Actually, commercial losses is part in my slides, right? Is part of water that you lost due to your theft, okay? The illegal water theft, illegal connections, your meter inaccuracies, and data handling error.
thank you.
What more? This one from Joe Balingit. Are firefighting withdrawals considered to be part of the NRW? I'm talking of normal situation where they are fetching water directly from our hydrants and they are not being billed. The firefighting, I've already mentioned, this is part of your unbilled, unmetered consumption. If your fire hydrant is not metered, okay, this is unbilled, unmetered consumption. In the Philippines, I believe, no, it depends if your utility has a regulation for the BF3 or Bureau of Fire Protection to pay for the water that they've been using from your hydrants. But general, I think they're not paying for this one. So, but to answer your question, this is not part of your. This is part of your NRW, but yeah, this is part of your NRW under the unbilled unmetered consumption. But you need to quantify this one. Just to mention an example, in Indonesia, specifically in Jakarta, they have all their fire hydrants metered, and it's the government that pays for this for the consumption of water from the fire hydrants. But of course, the tariff is very very low. Okay,
All right, thank you.
firefighting withdrawals is part of your NRW.
Okay. So actually, we have extended from 15 minutes. We're running 20 minutes for our Q&A. So I believe Ryan can answer one last question, and then for the rest of the questions which are not addressed, don't worry, we will send them all to Ryan and ask him to answer them, and then we will forward it to all the attendees of this webinar. So one last question, you can choose one.
Okay, from Mirlo Reyes. Hi Ryan, where do the top-down and bottom-up water balance can be applied? Actually, yeah, the software that I've shown you is to the water balance software is used uh, you normally use to assess the NRW situation of the utility as a whole. Okay, but if you want to use that on a DMA level or DMA level, you can also do that. But the bottom-up water balance, I have not discussed that here. Usually is being used if you have log data. So this can be used in a DMA level. But of course, if you use whether you use top down or bottom up water balance for a certain area, okay, if you are able to at least meet the requirements, the data requirements for this one, they should reconcile, they should give you the same results. Okay, so you can fine tune the estimates that you do in your top down as well as in your bottom up so that they will reconcile, they should give you the same result. I hope I was able to answer your question, Weirdo.
All right. Thank you so much for that, Ryan. And again, we will compile all the other questions and we'll try to send it via email to all the attendees for everyone's benefit. So thank you so much again, Ryan, for your time and for answering all the questions. So also, what will happen next after this webinar? As I mentioned earlier, we will be sending you access to the recording and the presentation of this slide. We'll give you a link via email. Also, together with the email that will be, or I mean, on a separate email, we'll be sending you a survey form. Because of course, we want to improve and be better in what we are doing, and we appreciate if you will be able to answer those webinar survey forms. And then we will also include there the registration links for the next two webinars. So don't worry for those who are not yet able to register for the two other webinars. We'll be sending a link to you. So just so you know, second part will be the flow and pressure data management by Gary Wyatt, who's also an IWA water law specialist, and he's a managing director of Wyatt and Water Consultant. Third part will be on June 26th. This time is a different one. It's 4 o'clock p.m., so take note of that. Introduction to Leakage Detection by Stuart Hamilton, also an IWA water law specialist and international business development from NIA Water. All right, so again, if you want to know more about AJA Marketplace, please visit aja-marketplace.com or you may send me an email directly. Customer registration is free for this platform. So thank you so much, everyone. Thank you, Ryan, for your time. Thank you for all the participants, and we appreciate you. We appreciate your time. Thank you, and have a wonderful day ahead.
Thank you, everyone.
Thanks.